Hi guys, so in this video we are proving a pair of segments congruent after we prove a pair of triangles congruent. This is the problem from the quiz review warm-up, and I've chosen to do this problem because there's two different ways to go about this proof, both of which are totally correct and legitimate. So I want you to see the different options that are out there when you're writing proofs. So the first thing that I'm going to look at is my prove statement. I need to prove segment PN is congruent to segment IN. That's this segment here and this segment here. So I'm going to draw these two triangles separately. Triangle PAN and triangle IAN, because if I can prove those two triangles congruent, then I know I could prove those segments congruent, because if two triangles are congruent, then all pairs of corresponding parts are congruent, meaning corresponding sides and corresponding angles. So I'm going to look at my first given, which states that angle 1 and angle 2 are congruent. Now, neither of those angles are in the two triangles that I need to prove congruent, but they are supplementary to the angles that are in the triangle, angle APN and angle AIN. So I'm going to have to write something about the fact that those pairs of angles are linear pairs and why. That's something that I'm seeing from the diagram. And this given, after I say a few connections, is going to allow me to say that angle NPA is congruent to angle NIA. And then the other given is that NA is perpendicular to PI. So I know these angles here are right angles. So far that's two statements about sides or angles being congruent or having some sort of relationship. And in looking at this diagram, I can see that the last statement is going to be about segment AN. It is the same segment in both of the triangles, so it is congruent to itself. So in looking at this, I can know that these two angles that are right angles are congruent because all right angles are congruent. So it looks like I could prove these two triangles congruent by angle side, because I have two pairs of congruent angles and then a non-congruent side. So that's one option for proving these triangles congruent. Another option would be to use the leg angle theorem, because when you have a right triangle, which I have here, these are right angles, so these two triangles are right triangles, and a pair of legs are congruent and a pair of angles are congruent, then you can use the leg angle theorem. And instead of saying in your proof that these angles are congruent, what you need to use is that the right angles result in right triangles. If you want to use the angle side postulate, you need to prove that those right angles are congruent. And if you want to use the leg angle postulate, then you need to prove that these triangles are right triangles. And that's the big difference between the two ways to approach this proof. So I'm going to first write the proof for angle side. So I'm going to start with the given. It is given that angle 1 is congruent to angle 2. Now I know that angle 1 is supplementary to angle NPA, and also that angle 2 is supplementary to angle NIA, because angles that form a linear pair are supplementary. Then this allows me to say that angle NPA and angle NIA are congruent because angles supplementary to congruent angles are congruent. So angle 1 is supplementary to NPA, angle 2 is supplementary to NIA, angle 1 and angle 2 are congruent, so NPA and NIA are congruent. Okay. My next given is that NA is perpendicular to PI. So angle PAN and angle IAN are right angles because perpendicular lines intersect to form right angles. Now, if I'm taking the angle side approach, I need to say that those angles are congruent. So angle PAN is congruent to angle IAN because all right angles are congruent. Okay, picking up where we left off, so far in our proof, we have said that these angles are congruent and also that these angles are congruent. So I need to say AN is congruent to AN by reflexive property. And then I've said enough to say that the triangles are congruent. So triangle NAP is congruent to triangle NAI by angle side. And therefore, PN is congruent to IN because corresponding sides of congruent triangles are congruent. Now, as I mentioned earlier, the other way to do this proof would be to do leg angle, and the only difference in that is that instead of proving the two right angles are congruent, I need to use the fact that those right angles make the triangles right triangles. So I'm going to start with the same thing that I started with. It is given that angle 1 is congruent to angle 2. Then I'm going to say angle 1 is supplementary to angle NPA, and angle 2 is supplementary to angle NIA. So angle NPA is congruent to angle NIA because angles supplementary to congruent angles are congruent. Then I'm going to take the other given about the parallel lines, also given that NA is perpendicular to PI. So still those angles are right angles because that's what results from perpendicular lines. So NAI are right angles because perpendicular lines intersect to form right angles. Now, instead of saying that those two angles are congruent, because all right angles are congruent, I'm going to say that triangle NAP and triangle NAI are right angles. Actually, they're right triangles because a triangle with one right angle is a right triangle. Then I'm going to continue on with what else I knew. NA is congruent to NA by reflexive property. So triangle NAP is congruent to triangle NAI by leg angle. So you use leg angle when you have right triangles, which I have said here in my proof that these triangles are right triangles, and then you have one leg of one triangle congruent to one leg of another triangle, that's AN in each of them, and then you have another pair of angles, so in this case this angle I and this angle P are congruent, so that's leg angle, and instead of saying that these right angles are congruent, you're saying that these right angles result in right triangles, and then you use leg angle instead of angle side. And I'm not going to continue the rest of the proof because the last statement, the concluding statement of what we need to prove, would be the same. Thanks for watching.